What if a single Ukrainian fighter jet could outsmart an entire Russian air defense network and live to strike back? At 1441, a Ukrainian fighter jet erupted upward from below the radar line, afterburners detonating into white fire. In less than 5 seconds, airspeed surged past 940 kilometers per hour. The aircraft absorbed nearly 1.2 tons of thrust as it slammed into hostile airspace. This was not an approach. This was total commitment. Under the wings, 2 Western precision weapons hung silent but awake. Each weighed over 300 kilograms. Their internal systems were already drawing power. Gyroscopes were spinning at thousands of revolutions per minute. They had been aligned more than 35 minutes earlier. Once airborne, recalibration would be impossible. One corrupted signal or one loose connection would cause the mission to collapse before it truly began. A Russian low-altitude surveillance radar registered a fragmented return at nearly Mach 0.8. The signal appeared, vanished, and reappeared again. Each time, it was displaced by hundreds of meters due to terrain masking. The track quality never stabilized above 40% confidence, but protocol demanded action. An interceptor missile launched, accelerating past Mach 3 within seconds. It flew toward an intercept point calculated on assumptions that were already outdated. The jet slipped behind a rising ridgeline. Its radar cross-section collapsed from multiple square meters to mere background noise. The missile seeker searched and recalculated, then lost its lock entirely. Moments later, it self-destructed, scattering fragments across an empty sky. The defense had reacted within seconds and still failed, but the pilot felt no relief. In moments, the aircraft would have to climb. When it did, stealth would end and the real fight would begin. At 1445, the pilot forced the jet lower, pushing it back into the folds of the terrain. Altitude dropped to 110 meters, then briefly to 95. Tree lines blurred into green streaks beneath the canopy. At this height, the aircraft had less than 3 seconds to react to obstacles rising ahead. There was no room for error, only momentum. Electronic warnings flickered. The GPS signal, already weak, began to degrade sharply. Error margins climbed from 2 meters to 20. Then worse. Satellite navigation was being jammed from somewhere deep behind the border. The pilot switched modes, feeding the system inertial data while glancing at a paper map taped to his leg. This was old-school navigation in a war of algorithms. Speed stabilized around 780 kilometers per hour. Any slower, and the jet risked falling into radar engagement envelopes. Any faster, and the fuel burn would spike past survivable limits. The margin was razor thin, with less than 5% tolerance either way. Ahead, the landscape funneled into a narrow valley. The aircraft slid into it, cutting radar exposure windows to fractions of a second. Each ridge bought silence. Each clearing risked detection. Inside a Russian command vehicle, operators watched their screens fill with uncertainty. Radar returns blinked in and out, displaced by hundreds of meters. The signal was never long enough to form a firing solution. Track confidence hovered below 50%, making it useless for a coordinated interception. But the pilot knew this advantage was temporary. Fuel readouts continued to fall. With the engine still at high demand, reserves were shrinking towards single-digit minutes. Worse yet, this flight path was about to end. Ahead lay the final terrain barrier. Beyond it, the earth flattened. There would be no more places to hide. To reach the release point, the jet would have to climb. When it did, every sensor would lock on at once. At 1450, the jet exploded out of the valley. The nose pitched sharply upward as the pilot pulled through 6.4 Gs. Altitude climbed violently to 2,500 meters, then 4,800. The engine screamed as fuel flow surged beyond 98 kilograms per minute. There was no cover now. The aircraft was fully exposed. It was a dark shape clawing into the open sky. Below, the compound snapped into view with brutal clarity. Rectangular buildings were arranged in tight grids. Vehicle shelters were aligned with military precision. Power generators glowed hot. Armored vehicles were idling. Antennas were alive with transmission. This was not a dormant site. It was operating at near full capacity. The pilot locked the aircraft into the attack profile. At just over 6,600 meters, airspeed stabilized near 830 kilometers per hour. The release envelope was narrow, measured in seconds. Any delay would push the weapons outside of their effective parameters. There was no hesitation. Both bombs released simultaneously. The aircraft jolted as over 600 kilograms of mass vanished in an instant. The two weapons dropped cleanly side by side. Their boost motors ignited almost immediately. For a brief moment, they climbed, fighting gravity before rolling nose down. They committed to a near vertical descent. The jet broke away hard, rolling and diving to escape. It left the weapons to finish the job alone. Below, the base had no warning. The bombs fell through the sky at over 300 meters per second. Their profiles were too steep for standard intercept logic. The first impact punched through reinforced roofing at the center of the compound. It detonated deep inside. Concrete failed. Structural beams snapped outward. The shockwave rippled across the entire site. The second bomb struck less than a heartbeat later. It slammed into the vehicle staging area. Fuel tanks ruptured instantly. Fires erupted, sending heat signatures spiking across every sensor. Within seconds, power collapsed. Communications went silent. The base ceased to function as a coherent installation. Above it, smoke and debris climbed into the sky. Far beyond the blast, the jet was already gone. The strike was over, but the danger had only just begun. At 1451, as the pilot pulled away from the blast zone, the jet dropped through 5,000 meters. Speed climbed past 1,050 kilometers per hour. The airframe groaned under the stress. Control surfaces fought to keep the aircraft stable. Turbulence from the earlier climb rippled through the wings. Then, the engine coughed. The left engine's exhaust temperature spiked sharply beyond safe limits. Compressor efficiency collapsed to less than 40%. The resulting thrust imbalance slammed the aircraft sideways. The jet rolled left without command, losing altitude at nearly 30 meters per second. The pilot reacted on instinct. Right rudder, stick correction, throttle adjustments were measured in millimeters. The damaged engine refused to stabilize. It vibrated violently as fuel flow surged in a losing attempt to restore thrust. Fuel reserves, already tight, plunged faster than expected. Burn rates exceeded 110 kilograms per minute. There was no turning back. The strike had exposed the aircraft to every sensor in the region. Radar warning indicators multiplied across the cockpit display. Long-range search radars, fire control systems, and tracking beams locked in sequence. The jet's radar cross-section was now fully visible against the open sky. The pilot pushed the aircraft lower, trading altitude for speed. He tried to re-enter the radar clutter near the ground, but the engine damage made the descent unstable. Every correction risked a stall. Every second increased the chance of complete failure. Behind him, smoke from the destroyed base rose in a thick column. It was visible from tens of kilometers away. It was a marker pointing directly to his escape route. This was the cost of the strike. The mission had succeeded, but survival was no longer guaranteed. Somewhere far beyond the horizon, other systems were already moving to intercept. At 1500, distant search signals sharpened into something far more precise. A new symbol burned onto the pilot's display. Active targeting. Somewhere behind him, an interceptor had locked on. The jet screamed just above 300 meters, racing across the terrain. At nearly 980 kilometers per hour, every vibration from the damaged engine transmitted through the airframe. The cockpit had become a shaking cage. Control inputs felt heavy and delayed. Fractions of a second could mean everything. Then, the missile launched. The radar warning receiver spiked violently as the threat vector snapped into place. The interceptor was fast, accelerating past Mach 4. It closed the distance at over 1.5 kilometers per second. At that speed, reaction time collapsed to single digits. The pilot deployed countermeasures. Chaff erupted behind the jet in metallic clouds. Thousands of reflective strips dispersed to confuse the seeker. Electronic jamming surged to maximum output. Onboard systems pushed toward their thermal limits. Within seconds, the cockpit filled with heat warnings. The ECM pod was approaching shutdown temperatures. There was no room to outrun the missile. The pilot rolled hard, pulling the aircraft into a brutal defensive turn. He loaded the airframe with nearly 8 Gs. His vision tunneled, then dimmed at the edges. The maneuver forced the missile seeker into a high-angle tracking problem. Its guidance algorithms struggled to maintain a stable solution. The jet dropped lower to 200 meters, then 150. He dragged the pursuit into the ground clutter. The pilot turned perpendicular to the threat. He forced the relative motion towards zero. For a brief, critical moment, the missile's logic hesitated. The lock broke. The interceptor streaked past. It missed by less than 120 meters before detonating in a flash of fragments. The blast peppered the jet's tail. Warning lights flared, but the aircraft remained flying. The pilot didn't slow down. He stayed low, racing toward friendly lines. He knew that one evasion did not end the hunt. It only bought time, and time was running out. At 15:05, the jet crossed back into friendly airspace with almost nothing left to give. Altitude held just above 90 meters. The ground rushed past in a constant blur. Airspeed hovered around 860 kilometers per hour. He managed the throttle carefully to keep the damaged engine alive. Fuel warnings blinked relentlessly. Less than 2 minutes of usable fuel remained before a flameout became inevitable. The pilot eased the throttle, listening for any changes in vibration. The left engine was barely holding together. Compressor efficiency hovered near 35%. Exhaust temperatures fluctuated dangerously. Any sudden maneuver now could end the flight. Behind him, the sky was quiet. There were no new radar locks and no missile warning. The hunt had faded. The jet had slipped back into the noise of terrain and distance. Ground clutter swallowed the aircraft's signature, just as it had on the way in. The pilot stayed low, following a pre-planned escape corridor. He avoided populated areas and known sensor coverage. Every ridgeline was a shield. Every river bend was a layer of protection. He did not climb. He did not accelerate. Survival now depended on restraint, not aggression. Minutes later, the radio crackled. A brief transmission confirmed what the pilot already suspected. The target was no longer operational. Power was out. Communications were silent. Vehicle activity had ceased. The strike had done exactly what it was meant to do. There was no celebration. The aircraft limped onward, crossing the final checkpoint. Fuel gauges were nearly empty. Systems were degraded. The pilot's hands shook. Not from fear, but from exhaustion and the after effects of sustained G-forces. When the jet finally disappeared from hostile skies, there was no dramatic ending. There was no victory roll. Just a damaged aircraft, a conscious pilot, and a mission marked complete. The war would continue, but for this moment, silence was enough. When the smoke cleared, there was no moment of celebration. There was no triumphant radio call or dramatic return filmed from the ground. There was just the damaged aircraft rolling to a stop. Fuel tanks were nearly dry. Systems were overheated. The pilot had pushed both machine and body beyond safe limits. The mission log would later mark it as a success, but nothing about it felt clean. This is what modern warfare actually looks like. It is not perfect weapons or flawless execution. It is systems breaking under stress. It is human judgment carrying the weight when automation fails. Victory is measured in disrupted supply lines rather than destroyed symbols. The strike worked not because everything went right, but because enough things worked when they had to. Both sides brought advanced technology to the fight. Radars detected, missiles launched, and countermeasures deployed. And yet, the outcome hinged on timing, terrain, and decisions made in seconds. A missed lock, a delayed response, a pilot who kept going when turning back would have been safer. That is the uncomfortable truth of conflict. Success often belongs to the side that endures chaos better. It belongs to those who adapt, not those who appear strongest on paper. So let me ask you something. If you were responsible for that mission, knowing it would be messy and risky, knowing it was far from guaranteed, would you have authorized it? Would you have trusted one aircraft, one crew, and a narrow window of opportunity to change the situation on the ground? If you want more stories that break down modern warfare beyond the headlines, if you want to understand what really decides battles, make sure to like the video, share your thoughts in the comments, and subscribe. Real war is rarely cinematic, but its lessons matter.